Hello, welcome to Beyond Cloud. We just solved the last big puzzle of mankind connecting a laptop to two beamers. And we made it. That's great. Great news. It's one of those fancy USB-C MacBooks, so don't get me started on that. But I'll get started on cloud. The one thing that I don't see are the flipping sides. That's the one thing I did not test. I hate technology. Yes, that's me. That's my company. My name is Torsten. I come from a company named Shopping24. Nobody of you will know it, and that's perfectly fine. We're doing e-commerce product search. It's not a product. I'm not here to sell you anything because I don't have anything to sell you. Just if you're looking for a new shirt or new jeans, just click on our advertisements in Google search. Then I'm happy. Then I get paid. I like that a lot. Yes, we have an e-commerce search engine built. We have around 60 million products, so it's a huge database we have to search. We deliver about 2,000 on-the-fly scaled product images per second. We have about 1,000 searches per second. And I thought I'd count the CPU because I'm on a more ops-minded conference, and I counted to about 1,000 CPUs, then I stopped counting. We have lots of RAM because search is very heap intense and imaging is also very heap intense. And everything runs on bare metal. So you might ask, so why does this guy say anything about AWS? I will. Right now it's running full on bare metal. That's the software stack. We use open source, we embrace open source, we contribute to open source. We have a lot of open source projects in the search community and lots of things in ops and whatever. So we contribute back. And we use pretty much everything that's out there in the market. If anybody from the team has a new database, we just deploy it and use it, and we feel so happy about it until it crashes. But that's another different story. So today I'm here to talk about AWS, our journey into AWS, and specifically our journey back from AWS onto bare metal, and why we did it and how we achieved it. So the thing is, I mean, cloud is far gone. Cloud is yesterday. Container is almost yesterday. Kubernetes is today. But cloud is yesterday. But it's like always with these hype things, the big corporates, they start adopting to this because it's solid now. I see a lot of companies, big companies, just saying, well, we're going to AWS, we're completely ditching our hoster, we're moving into the cloud, everything is better, and it feels like they're going to a party. But let me tell you, I've been to that party, and it wasn't that bright. Yeah? Because we hosted all our systems for 3 years on AWS, and now we're back on bare metal for pretty specific reasons. This is not going to be a hate speech about cloud providers, because they have their reason, they have their target group. But we discovered that we weren't one of them, so we just moved out again. So this is a emerging story nobody likes to hear, but in the end I hope you listen. And the main message is, use your brain when deciding for a hosting provider. Use your brain. That's the main thing. So the story I'm going to tell is a nice little encapsulated hosting thingy we were doing. It's delivering millions and millions of product images in real time, on the fly, scaled to the user. And that was one of the first service we moved to AWS because it tends to it. Yeah? So that's a typical product page when you look for, I think, evening wardrobe on Fashion 24. You're not the target group. Not, well, 5% maybe. Or only in private, okay. So that's the typical search entry for evening wardrobe, and it's just the request is hitting the PHP servers, they are rendering the portal, they are requesting through hundreds, millions of, feeling like that, microservices through back to Solr. The search is retrieved. So we have one search in Solr, we have one PHP hit, but we have like 96 images, yeah, for one request. We don't have that much or many recurring users, so most of them just come once, they look for a wardrobe, and then they buy a wardrobe. We have to deliver those images a lot of times. So these are just some random graphics from imaging. This is the typical curve we print out. We have up to 400 megabit of output of images at peak time. And yeah, our caches run at a hit rate at about 100 to 99%. So most of the things are cached by Varnish, Nginx, and whatever. But more of that later. So let's start with the basics. Who is, now is the hand-raising thing? Hand-raising thing. Hand-raise. I promised beer, so every good question receives a beer. It's still cold. That's important today. And don't ask me for date or time, yeah? To that theme. Yeah, who's familiar with AWS and the products, let's say the basic products? So, 50%, okay, I'll just cover this very quickly. So AWS is, I don't know how many products I have, over 1,000, I guess. At least it feels like it. We started back then, in the old days. We started with a pretty simple set. We had a storage. We needed storage. Storage is S3. We needed compute power, which is EC2, where you just can grab your virtual machines, spin them up, they get an IP address, and you're online. It's pretty easy. You just inject an operating system, you install your software, you're done. Perfect. We use the Elastic Load Balancer, which is a load balancer distributed by Amazon, where you just register your machines behind. You have a public-facing IP address, and you put your CNAME on it, and requests get evenly distributed to your servers. We used CloudFront, which is their content delivery network, which has entry points across the globe, not only in the data centers, and they do some caching at these edge locations, how they call them. And we were great users of auto-scaling, where you just can define a group of servers and say, I want 1, 2, or 200 instances of those servers. And you can just scale them on the fly. They get reproduced. And in the middle of the talk, I'm going to talk about spot instances, which is very, very funny little concept where you can bid on overcapacity in Amazon data centers. We use those a lot, and you get very, very big machines for very little money. And as a CTO, I like that. Yeah? There are some downsides, but you can basically it's shopping at Aldi. So let's start with the good part. The good part about AWS is that resources are immediately available. You want a server with 160 CPUs, you want it now, you get it now. If you pay for it, of course. But yeah, you get it now. And on the other hand, there was, we were no storage experts. We had a storage, a NetApp, a very old NetApp, a very slow NetApp, which reached its maximum capacity at 500 gigabyte or something, old days. And storage is hard, and deciding on a storage and buying a storage involves a lot of money. Sometimes it's cheaper to buy a house. So we decided, let's just move into Amazon, which is where you just pay what you use. Because if you buy a storage system, you have to plan your capacity. You have to say how many terabytes I want for the next, I don't know, 3, 5 years, whatever, 10 years. At Amazon, you pay for the gigabyte for the hour. So perfect need for us. And that was what we wanted to go for. So we wanted to do image scaling on the fly, and that's the roughly scheme. We used S3 storage as the original image storage, where we just imported heaps of images. We had, oh, let's try the fancy feature. Just works here. We have the resized images, where we, a dedicated bucket where we had some kind of temporary cache. So if you scale an image from like 1,000 pixel by 1,000 pixel to 50 by 50, that's a costly operation, and you just store them in the resized image bucket for like 30 days. They have a auto-destruction mechanism in, at Amazon, and they just remove them after 30 days. So we have a public CloudFront location at the edge. We have an elastic load balancer. We have 2 cache machines. They just look up in the resized image bucket. If there's no image, request the scale on the fly. If the image is in the bucket, just deliver it. Pretty simple setup. So, was easy. In terms of ops, was a nightmare. Handcrafted virtual machines coming out of nowhere. Let's say provisioned during some heavy beer sessions. So. Not at all reproducible. So it was a nightmare driving it, especially as we discovered that we weren't doing so bad. So more images needed to be scaled on the fly, more images need to be stored. That was a problem, Amazon's problem, not our problem, but scaling more images on the fly, you need more CPUs, you need more RAM, and yeah, you need more machines. So that's a kind of problem then, if you have handcrafted virtual machines. So snowflakes everywhere. And what we did, we wanted to autoscale everything. So we said, okay, autoscaling is super cool, and we know that in the evening we have a lot of image traffic, we just scale the group, and when we have less traffic, we just scale it down. Pretty simple. So, but let's see, the autoscaling mechanism, it has some caveats. So you have to decide on a certain machine size. It's always limited at Amazon. You have always fixed machine sizes, either a lot of RAM, or a lot of CPU, or a lot of disk. Not disk is not, but or a lot of throughput. So you have to decide on the one machine size, and they just come out of nowhere. If you have an autoscaling group, you just increase the size, and they need to be provisioned out of anything. So the thing that Amazon propagates is using an AMI, an Amazon Machine Image, that just which is like a net boot, and the machine gets provisions from this Amazon API, or this Amazon Machine Image. We didn't want to go that way because I felt it was like another nightmare beside our own code base. You have like, the thing is that you have, if you have the Snowflake machines, I was in fear of Snowflake Amazon Machine Images just building on top of each other with another package installed. And I wanted to do something better. So that's when Ansible came in play. And we switched host provisioning completely to Ansible, which is a credible tool. If you don't use it, if you don't have a provisioning tool, if you shouldn't have a provisioning tool, use Ansible. It's great, it's easy, it's just, it's very predictable, and it has this neat Ansible pull mechanism, where the machine gets instantiated by Amazon in this autoscaling group. When you need to autoscale, it pulls a GitHub repository, and it just installs itself out of the Ansible roles in that GitHub repository. Pretty easy. Will succeed like 80% of all the times. But it's pretty good. The plus side is you have all your code in a VCS. So everything is versioned. If the machine doesn't come up, you know what change caused basically your image delivery to fail. So that's good. Good thing. If there are any questions, feel free to ask right now. You get beer for it. Yeah? Quick reminder. The next thing is the bad. So we were pretty happy, but there's always rain at the horizon. So there were some things we needed to look at. The first thing was money. It was very flexible. We had lots of storage. We had lots of machines. But boy, we did not earn anything. Because machines, if you provision them on the fly, if you don't have any reserved instances, you don't have any percentage of by Amazon, you pay a lot of money for the machines. And we paid even more money than with our traditional hoster, because we had the flexibility. So it was a plus side. So in theory, you just reduce your machine count during the night. Reality says, oops, that job didn't run, or, oh, forgot it, let's just run through the weekend. So reality was we were just over-provisioned for like 20 hours a day. Just those 2 hours in the evening, they were provisioned very fine. So, but we did not want to go the path down with reserved instances. So you pay an upfront fee, and you have a reduced price for the instance for the next 1 or 3 years. We felt that was just wrong, because we came to Amazon for flexibility and not for 3-year contracts. So we wanted to avoid upfront fees at all. So, yeah. The spot instances are coming now. So we had just the on-premise instances, or just the usual, the normal instances, and now's the part where you can save some money. That's the spot instance part. They are fun to play with. It's a market. There are websites visualizing the Amazon spot instance market, and if you pay like a regular price, for instance, is like $2 per hour. It can be that at the spot instance market you get it for 10 cents per hour. That's great. That's a bargain. It can also be that the same instance, like an hour later, is at $5. It's just above the regular price. That's a perfectly, at first it looks insane. Why would I pay more for an instance if I get it for a regular price cheaper? But the thing with these spot instances is, if anyone pays more for it, your instance gets terminated instantly. It's like lights out. And if you have this process that needs to compute anything, and some guy started it on a spot instance, and you don't want it to be terminated at all cost, you just bump your spot price up to $5, $10, $50, and you hope that you don't get terminated, that there's not some monkey out there who's paying $100 for a spot instance that he can get for $2. That's sometimes it's a little strange, but in the end, most of the time, it was pretty cheap. Then it's this thing of multi-dimensionality. Now it gets a little crazy. You have a spot instance price for each machine size in each data center. That's not the region. You have the Ireland region or the Frankfurt region. Each region is divided into 3 data centers. Each data center has a different price for the same machine size. So here comes multi-dimensionality in play. You have 2 data centers. Each has no, you have 2 regions. We played 2 regions, Frankfurt and Ireland. You have 3 data centers, so you have 6 data centers. Six. And now you have, like, let's say, different machines. So the software was fine. It's image resizing. You need a lot of CPU. You need a lot of heap. So it's Java. So we did, okay. We like the C1. It's compute, high compute, extra large instances. They were fine. And then Amazon puts newer instances. They are faster, but more expensive. So we tried the C3, the C4, the X large, the 2X large, whatever. And in here, you can basically say, I want an auto-scaling group bound to a spot price. And as soon I want like 100 instances at maximum for a price, and I'm going to pay at most 20 cents, 50 cents. But that's the price for this instance size in that data center. So you have, if you want to bid on all available C1 X large instance machine on the spot market in 6 data centers, you need 6 auto-scaling groups. So we had like the hell of a bash script administering those auto-scaling groups, because we had like, I think, 8 machine sizes, 6 data centers, and you have to balance everything, because there are times when prices just fall and suddenly you have over 1,000 machines and it's just a little too much. Then there are times where there are 0 machines available and you need any fallback, any kind of fallback. So you have to learn with this. This is fun to play with, challenging, but you have to learn with it. You have to learn with the market mechanisms. We followed the word of Etsy. No, it wasn't Etsy. Who was it? I don't know. Who said, Netflix. If you want to save money at Amazon, use spot instances. Use them for everything. And we tried it, we failed, but there are compute resources you can use it for perfectly. And the one thing we learned was our software was not at all cloud native or even cloud ready. Because when a software terminates instantly, maybe you need to notify someone, you need to deregister from a load balancer. If you use an Amazon thing, it's okay, perfectly easy. But if you use anything in the back end, that's pretty tricky. So you have, if you have any image in download process or any resizing process, you have to terminate that properly. You have to propagate it to a next machine. You have to either deliver or send the request to the next machine to that he delivers the next or this resized image. So just imagine you have a server, you turn the lights off instantly, you just put shutdown and check your software if it's healthy afterwards, if it gets rebooted on another machine. And then there was the third thing was vendor lock-in. We just thought, well, we live in Amazon now. We want to leave our old data center where the software slowly migrates into the IP addresses and CNAMEs of the data center, where it just flows into the fixed path structure. I mean, everybody knows that software, and we were just migrating to Amazon to not have any vendor lock-in, but it's the perfect vendor lock-in, because if you have $100,000 a month spending on Amazon, they were really helpful with us. We had lots of engineering power coming from Amazon, lots of consultants, but if you spend $1 million a month, they won't help you at all, because you can never leave. It's impossible. So, yeah, we heard that a lot today. That's one of the ideas then. So we thought, well, we should have some boundaries when using Amazon. We were experimenting a lot with the other services. They just came on the market and we tried them. And we said we just want to limit ourselves to 3 services, which is compute, EC2, which is storage, S3, and the DNS service Route 53, which we are just throwing out of the usage right now. But EC2 and S3. But because if you use all these fancy features like relational database system, Redis, all the key value stores, you have a vendor lock-in. It's undeniable. You don't get out of Amazon anymore. And if you use a plain machine image, it's exchangeable. You have Ceph as an alternative to S3, so it's exchangeable. So we always check that. It was not always rain on the horizon. There were pretty neat things. We could, that's a thing you can do with Amazon very easily. We had staging systems at Amazon only. The developers and the ops guys pretty fast saw the chance to have multiple versions of a website auto-deployed via Jenkins to Amazon. That's pretty neat. If you have a VM, I mean, it's pretty ridiculous. It's commodity with Docker, but in those old days, it was pretty cool to have virtual machines, different code of the same website, different features, ready for testing on different machines. And it's pretty easy. Everything has an API, of course. It's an API-based service. You pull in public API, you pull your repository, you build your test server, you configure your DNS, and you're good to go. You have a button in Jenkins, deploy or die, and the die button removes everything, the deploy button deploys everything. That's it. But let's go to the ugly. That's the next thing. There are two very ugly patterns I saw emerge. The first thing is multi-cloud through a bottleneck. If you want to migrate your data center into whatever cloud, AWS, Azure, whatever, what I heard so far is always that we're the same with us. We were at capacity limits. And there's especially this one thing, this really expensive piece of hardware in your data center that is like the holy grail. Nobody wants to touch it. Any configuration change is always like, oh my goodness. Same with us. The firewall. The firewall is the hell piece of hardware. It's like you can buy a couple of houses for this one holy grail piece of hardware, and it's always under capacity, always. It never meets the specs, just in some ideal laboratory, and the same with us. We had a firewall we needed to replace because the traffic, they measure the HTTP throughput, was just skyrocketing. It couldn't handle it. So we wanted to move to Amazon, and when you connect the data centers, you need a VPN tunnel. The VPN tunnel terminates on, guess what? The firewall. And who needs to do all the encryption and decryption? The firewall. And who needs to handle all your live and online and your money-earning HTTP traffic? The firewall. And get what burned completely down? Yeah, the firewall. That's always a major problem. You have this one bottleneck in your own data center, which is the firewall, and then Amazon has lots of capacity on their side. They say open 2 VPN tunnels. In best case, route them differently, because if the one line gets shut down, the other one is still alive. You have data centers connected. This is not play stuff anymore. What do? You terminate the same things on the same firewall. You do the same lines. That's what I've seen the most. Not at our installment, but at other installments. So it's important to do this routing thingy, but it costs money, and most of the people don't do it. But my advice would do it, and do it before your firewall explodes. So that's one thing to look at. The other thing is what I call dual stack systems, which had nothing to do with IPv6 or v4. It's just that due to this limitation, of the traffic. I mean, on the other hand, you pay traffic on both sides. You pay traffic for leaving your own old data center. You pay traffic for entering your new data center. You pay twice for traffic, so you try to reduce traffic, try to reduce load on the database, on the firewall, and in the end, you build system twice. So we had 2 logging stacks. We had 2 Elasticsearch servers because we did not want to unify everything in one data center, because then everything has to go through the firewall or the VPN tunnel. And that costs a lot of money. So it's always you have to think what costs more money. Is it more reasonable to have 2 installments of those systems, which is not, or should I upgrade my firewall? So that's a thing. Nevertheless, we thought, well, it's not that bad. Let's go all in. And we there's this online calculator of hosting costs at AWS. We did some calculating, some shifting, some thinking, some it will fit. And then we said, okay, it may be cheaper, but it maybe it's just the same price, but we get more flexibility, which is great. So we did one last test, and the one last test was having our core components, the search, deployed at Amazon. And search is a beast. You need lots of CPU, lots of RAM, lots of IOPS, and lots of network, because you have a distributed search. We have like 20 nodes, huge nodes in our data center, and so we deployed it, and the performance was not nearly as good as in our old data center. And the thing was, nobody can see it, the thing was, you need 10 gigabyte connectivity. If you have a huge cloud instance, you have terabyte of data, you need to connect them. You need instances that are not only lots of RAM, lots of CPU, lots of SSD, but you need lots of network. So our calculation was completely wrong, because we needed all those fancy things down here, where you pay about between $1,000 and $2,000 per month per instance, and not those $300 we calculated with. So we thought, what if our old hoster was just horribly expensive? And Amazon is as well. Maybe there's another solution to our problem. So we did this cost comparison with a new hoster. I met 3 years ago at this event, or this venue here. And that's the outcome. The yellow thing is Amazon, where storage is pretty cheap. And the green thing is the new hoster, which is slightly cheaper. This is an example for our image caching and image storage solution, which involves a lot of RAM, not that much CPU, but a lot of SSD. I think total 2 terabyte of RAM and 4 terabyte of SSD spread over multiple machines. And yeah, that was kind of a game changer. So if they are like factor 8 cheaper, what does that mean? So we thought maybe we should go for, in terms of money, it would be wise to use a traditional hoster, just change the hoster. But in terms of flexibility, what does that mean? We loved the API. We loved configuring our network with Ansible, the machines with Ansible. We loved deploying new hardware or new virtual machines at Amazon. We still use AWS as disaster recovery. We like it a lot. We had a failure, massive failure in our image storage. And I think AWS is the only place where you can just deploy about 19 or 12 terabyte, I guess it was, SSD in like 2 seconds. That was pretty nice. And we needed it. We had just had an out time of 2 hours instead of a couple of days before some new hard disks arrived from Hewlett-Packard. So the thing is, how can we get the flexibility of Amazon into our own data center? That's the key question here. And the thing is, of course, we heard it a lot, cattle, not pets, you need a configuration management. And configuration management for your machines. You can, we use Ansible a lot, we use it for the transformation from Amazon, from the machine provisioning to your own data center is straightforward. It's just the same. It's just a different operating system that doesn't really matter. You can use the same Ansible roles, perfectly transformable. But where does it come? But we like this thing a lot. This is infrastructure as code. That's the next thing. We had all our Amazon virtual private clouds, all our machines, they were in Ansible. You had a changelog. Nobody used the web API. We just created new machines, new environments, new staging environments with the same rules you use for the production environment. That's pretty neat. Pretty cool. You have all your networking, your everything, every operational piece is in your VCS. That's cool. But in our new data center, we thought, how can we achieve that? So I still thought of all those old servers I learned in the insurance company I worked before, which were old bearded man hacked things into the console and a Tomcat appeared, or a WebSphere application server. But with the modern server chassis, you can do it just like on Amazon. You have a piece of hardware. We have this hosting contract, which I like to call Ryanair hosting. They're just plugging the bare metal into the rack. They just apply network and power, and everything else is up to us. The modern server chassis has a third network port where you have a small server listening to remote controls, which is ILO on the Hewlett-Packard side or IPMI on the Supermicro side, and you can just do a remote boot. The boot server decides it's this MAC address coming with a remote boot. You are going to be a database server with this hardware layout. You are supposed to have these SSDs. Enjoy the party. We have from server into the rack, power on to live, we have less than 30 minutes. But that's just the time the operation system needs to install some Postgres stuff. So it's completely automatable, and nobody needs to do anything on the console anymore, even if you do that in your own data center. That's some random screenshots from a HP server installing. So, yeah, that's the Pixie boot we do. What's missing here? The new players. I mean, it's an old story. We moved back to the bare metal 2 years ago. So what we didn't consider was the Docker service at Amazon, which is pretty interesting. Even more exciting is the Elastic Kubernetes service. All the Lambda stuff is missing, serverless is missing, which has the potential to be a game changer in terms of money. If you just pay for execution, that's perfect. So that's I don't know if we need to check on that in the future again. But in the end, we have a very strong shift in our company towards Kubernetes. We use it a lot, we love it a lot, because it's this perfect abstraction above your data center. I pretty much don't care on what machine this service is running or on which data center this service is running, as long as it's running. So you just deploy to Kubernetes. We plan to span it across AWS as well, because we want to use all these funky graphical GPUs, and we don't want to buy them when we're trying. And that's the thing you can do with Kubernetes. You just don't have to adapt to a data center. So the message pretty much is, if you have a data center, and I mean, we're on a DevOps con, you pretty much may have it. Take back the control. Put all your operation into a version control system. Your infrastructure needs to be there, your firewall needs to be there, your servers needs to be there. Use cloud principles in your own data center. Make your software cloud ready. Make it refactor your software to make it instantly turned off. Be ready for some auto-scaling thing. Be ready for Kubernetes, because Kubernetes does nothing else than auto-scale things and rescale things. And nobody wanted a beer yet, so this is the thing to take home. AWS is great. If you're a small company, it's great. You're very flexible, but AWS is not for everybody. So use your brain. Put everything into VCS, automate all the things, and I'm pretty happy to hearing the question less, what is better, cloud or bare metal, because as long as your software is running, you don't care where it's running. So that's the message, and I hope you have some questions. I have 6 beers left. So that's it. Yes. There was one? Yeah. Sorry? It was this Ansible pull thing.
What was the main reason of the 20%?
The 20% were commits into the branch without testing them. Because when the next time the branch gets checked out from the autoscaling group, it broke. Just some random things. Some not even image-related stuff. That was just engineering failure. But in the end, it's very solid. It runs pretty well.
Why did you build network images? I mean, why did you pre-build them?
We thought about it. The tools weren't right at the time. And we just started using Ansible, and we wanted to have all operations in one place. So we thought, now I don't think it's the brightest idea, but we thought, have everything in Ansible and just apply the rules, the Ansible rules or roles to the new created server. So the problem with that approach is that the boot time is pretty long because you have to install all the things. If you have a pre-baked API, you get your images instantly. So maybe now it's better.
You can still use Ansible to pre-build those images.
Yeah, that's right. That's right.
And then you get an architect to roll back on it.
Yeah. So the annotation was you can use Ansible to build an AMI, Amazon Machine Image, and you have that versioned, and you can roll back and forward on those Amazon Machine Images. That's right. 4 more beers. Yes. Not really. At that time, they hadn't any compute resources. Oh, perfect. Thank you. So we tried out Google. We liked Google a lot, but it was very limited at the time and did not have the virtual machine approach then. And it's, I mean, the cool kids want to do cool stuff, and if everybody on the block is doing AWS, you want to do AWS. So, yeah, no.
Have you tried Direct Connect?
No. No, because of the data center, the question was if you tried Direct Connect, you have just a limited number of data centers in Germany providing Direct Connect, and we weren't among them, and still not are. 3 beers left. The old provisioning. The what? We managed that through spot instances. So we were still over-provisioned, but we did not pay that much. So, 2 beers. Yes. Yeah. The question was, did security concerns, did we pay attention to security concerns when using Amazon? We had all the IAM stuff in place, and enjoy. We had the IAM roles in place. We had everybody had a personal account. We had different networks. So in terms of network security, I think, it's a complex network. In your data center and at Amazon, it can get really ridiculously complex, and we did that. You have, with the security groups, you have pretty good overview which service is allowed to connect with which other service. In terms of, we're in the lucky place that we are not a shop. We don't have any personal data. We don't have any customers, any customer data, so we were pretty happy about that, and we could just skip that part when hosting stuff on Amazon. So, last beer. Just one. Which one? I'll tell them. Okay, beer's out. I'm here for questions. Thank you very much.